Okay, so for this video, we'll be doing the G3 Sc on pressure. Okay, so this is a success criteria. Recall and apply the relationship pressure equals to force over area to new situations or to solve related problems. Okay, so we are solving I1 all the way until I5. Alright. Okay, so let's start. So in this question, a cube of side 0.2. So if you know that it's a cube, that means all sides will be the same. So the length is actually 0.2 meters and it weighs 100 Newton. Okay, so the force is downwards 100 Newton. So this is the weight. Okay, and it rests on the floor. So what's the pressure exerted by the cube on the floor? Okay, so the formula pressure equals to force over area. And since we have weight, which is a force, we have this component already. We are supposed to find pressure. So now we need to find the area that is in contact with the floor. Okay, in contact with the floor. So we substitute force as a 100. Area is actually length times length. So 0.2 times 0.2. And then we'll be getting this value. Okay, so the answer will be 2,500. Okay, because it's in Newton per meter square, so we can leave it as 2,500 Pascal. Okay, because Newton per meter square is also Pascal, right? Okay, now I2. A cube of side 20 cm, so again it's a cube, so all the sides are the same length. So the length is now 20 cm. Okay, so if we want, we can actually change it to 0.2 meters first, right? And then this makes it the same dimension as I1. Now, given that the cube has a mass of 10 kg, so this is the mass. What's the pressure exerted by the cube on the floor? So again, the formula is pressure equals to force over area. So since we know that the length is 0.2, we will know the area. But how about the force? Okay, recall in this early on in this chapter, W equals to mg, right? So instead of giving you the weight, I'm now giving you the mass, which is 10, and we take the G as 10 for Earth. So it is 100 Newton. Okay, so this makes it exactly the same questions as I1, just that I'm playing with the units, and for the weight, I never give it I don't give you the value direct. Okay, because it's also tied in with this chapter. So you have to make sure you know what you are putting in for the values. So in the end, you still get 2500 Newton per meter square. Okay, so we can also leave it as 2,500 Pascal. Okay, so either Newton per meter square or Pascal is acceptable. Okay, now a cubic block is placed on a table such that one side of the block rests on the table. The pressure exerted by the block on the table is P. So let me just draw a very quick diagram. So the pressure exerted is P. Okay, so now they're asking what's the pressure exerted by the block on the table if the lengths of all sides are double. So maybe I call this X, X, X because it's a cube, right? So the mass or the weight, let me call it W. Okay, so for this cube, the pressure that is exerting on the floor is P. Okay, I'm letting the weight to be W and I'm letting all the sides be X. Okay, now what if this cube is having all the sides double? That means this will be 2x, this will be 2x, and this will be 2x. They are asking for the pressure of this big cube. What's the pressure, okay, of this bigger cube? Okay, so now we need to determine what is the weight of the new cube. Okay, so if you have played with Lego or building blocks before, you know that there are actually 8 of this smaller cube in there, right? Okay, so because this is 2x, so over here is made of 2 cubes. This is 2x, 2 cubes, and over here 2x, that means 2 cubes, right? So total there are 8 cubes. So if each small cube is W over here, so the weight of this bigger cube, where all the lengths of all sides are doubled, will make it 8 times W. So it is 8W. Okay? And using the formula, pressure equals to force over area. Now it is 8W. How about the area? The area is now 2x multiplied by 2x. So I will have 8W over 4x squared. That means I'm going to have 2W over x squared. Okay. For this smaller cube, the pressure is force over area, W over x squared. So that means the pressure that the bigger cube exerts on the floor is 2p. Okay, instead of p, it is 2p. Okay. So a twist to this question is, what if the length is triple, or what if the length of all sides are half? Okay, so you have to sort of use algebra and then think of how many cubes are there. All right. Okay, I4, two identical boxes are placed on the surface. Explain which one exerts a greater pressure on the surface. So if this is A, block A, this is B, so B will exert a larger pressure. Okay, because let me type out the answer. Okay, so both boxes have the same mass, therefore they have the same weight, right? But box B have a smaller contact area. Okay, so you cannot say surface area because actually they have the same surface area. But if I'm talking about contact area, it is the area that is in contact with the floor. So if I were to shade out, it will look something like that, right? Or smaller surface area in contact with the floor. That means I need to see contact area and not surface area. And bring in the formula to help you to explain. Since pressure equals to force over area, right? Box B will exert a greater pressure because the area is smaller, but the force is the same for both. Therefore, the pressure is greater by B. Okay? Now, I5, last question. A cylindrical mass of 300 kg. So this mass is 300 kg. Okay. Always underline the numbers and make sure that you know what it is. It's supported by 3 square blocks placed on the ground. Each block is of negligible mass. That means we don't need to care about their mass. And each side of the block has an area of 1 meter square. Okay. That means this block, this area will be 1 meter square. That means I already know the area. Okay. So calculate the pressure that the mass exerts on the ground. The mass of this whole thing. So part 1, pressure equals to force over area. Okay. But we are not given the force. We are just given the mass. So we need to convert it to the force. So use W equals to mg, and G is 10 on Earth. So we can use 300 multiplied by 10. So it is 3,000 newtons. Therefore, the force over here is 3,000 newton. The area, okay, because there is now supported by 3 blocks, therefore the total area will be 3 times 1. So the answer will be 1,000 Newton per meter square, which is also equals to 1,000 Pascal. Okay, you can either leave it in Newton per meter square or in Pascal. So part 2, calculate the pressure that each block exerts on the ground. So now they are talking about each block. Okay, so how can we do this? Well, I can think of this mass, okay, being divided into 3. So now each block will actually handle 1/3 of the original mass. So 1/3, this is going to be 100 kg. This is going to be 100 kg, and this is going to be 100 kg, assuming I divide the mass equally into 3 parts. Okay, so because each block handles only 100 kg, so let me do my calculation again. Pressure equals to force over area. Now what is different this time is that the weight or the force that each 1/3 of the mass exerts is 100 multiplied by 10. Correct? Using W equals to mg. but now the area is 1 meter square. Therefore, we still get the same value of 1000 Newton per meter square, which is 1000 Pascal. Alright, so some of you may think that it is 3000 Pascal, or you have come up with some other answers. The answer should be the same. Alright.